Hi, I'm Phil Webb, Principal Consultant with Select Business Solutions. The computer is an amazing invention. On a daily basis, it seems, new applications arise, changing the way we live, work and play. Computers are used almost everywhere we go and have moved from providing occasional assistance almost to the point of being essential for day-to-day life. In this initial module, we'll explore the early days of computing and examine how the decisions made 5 or 6 decades ago have shaped the world in which we live and the industry in which we work. The 6th of May 1949 is considered by many to be the birthday of modern computing. That day, some 60 years ago, saw the execution of the first stored program on the EDSAC, the Electronic Delay Storage Automatic Calculator, at Cambridge University in the United Kingdom by Maurice Wilks and his colleagues. EDSAC's first programs calculated a table of squares and a list of prime numbers, and its initial orders, a set of routines which allowed subsequent loading of programs, were programmed using a series of telephone exchange switches known as uniselectors. Further input was given through the use of holes punched in paper tape, similar to the punch cards used by IBM's electric accounting machines, while output from the program was given in the form of printout on a teleprinter, a kind of automated typewriter. Newspaper reports at the time labelled the computer a mechanical brain, and they describe its vastness, weighing about a ton, with 120 racks of valves and covering an area of about 500 square feet. In a pre-echo of later predictions of the number of computers that would be required, The Star, a popular London newspaper, reported that a dozen or so such brains would probably be sufficient for the whole country, and that one day the brain might help with our income tax and bookkeeping calculations. Maurice Wilks saw a purely scientific future for EDSAC, stating that the brain would carry out mathematical research and might even make sensational discoveries in engineering, astronomy, and atomic physics. In May 1950, the Pilot ACE, or Automatic Computing Engine, ran its first program. The Pilot ACE was intended as a prototype for the ACE itself, which embodied the ideas of the mathematician Alan Turing, now well known for his code-breaking machines during the Second World War, as well as for his theoretical work on computation. Turing is particularly renowned for his conceptual discovery of the universal Turing machine, a computer structured not to carry out specific tasks, but which can carry out any task specified by programmed instructions. At a symposium on large-scale digital calculating machinery in 1947 in Cambridge, Massachusetts, Turing said, "We're trying to build a machine to do all kinds of different things, simply by programming rather than by the addition of extra apparatus." Just 2 years after the first programs were run on EDSAC, UNIVAC-1, the first commercial computer, was produced in the United States. Designed from the outset for business and administrative purposes, it was built for the fast execution of large numbers of relatively simple calculations and data transformations, rather than the complex mathematical algorithms for which the EDSAC had been designed. Magnetic tape was used for input rather than punched tape, and early installations were used by the US Census Bureau, Air Force, Army Map Service, and the Atomic Energy Commission. 1954 saw the first installations of the UNIVAC for commercial use by Remington Rand, then owners of UNIVAC, in their sales office, then by General Electric, Metropolitan Life, US Steel, and DuPont. Meanwhile, in 1951, Lyons, a United Kingdom food company with a chain of tea shops, had commissioned the Lyons Electronic Office, or LEO, initially to run valuation jobs. Leo was designed by EDSAC's Maurice Wilks, and its functions were subsequently extended to include payroll and inventory. These were perhaps the first business applications to run on an electronic computer. Even in its early use, Leo was able to provide great value to Lyons, elaborating daily orders which were phoned in every afternoon by J. Lyons shops and then used to calculate overnight production requirements, assembly instructions, delivery schedules, invoices, costings and management reports. Arguably the world's first integrated management information system. 1951 also saw the commissioning of the first real-time computer. Whirlwind was built at the Massachusetts Institute of Technology for the US Air Defense System and was the first computer to allow users to interact with it using a keyboard and a cathode ray tube. Project Whirlwind was originally instigated to create a computer to run a flight simulator for bomber crews, an activity where the typical batch mode of existing systems would not suffice. However, programming continued to be by means of sequential instructions on paper tape, and later magnetic tape. These early years in computing history saw very rapid redesign of the computer hardware, so that the programs they ran needed to be redeveloped with each change in the hardware. In 1952, Grace Hopper completed work on the A0 compiler. Although A0 used a series of symbolic mathematical codes rather than English-like words, it paved the way for later programming languages, which would dramatically increase programmer productivity and understanding of the software they were writing. Its use of numeric codes to identify subroutines greatly simplified the programming of machines such as the UNIVAC, although a commercial compiler for the UNIVAC wasn't released until 1957. During the mid to late 1950s, 4 major programming languages were developed, which would provide the platform for most of the programming techniques in use today. They were Fortran, Lisp, Algol, and COBOL.